Assalamualaikum. My name is Afiqah Binti Chailan with metric number AN1834. My supervisor's name is Dr. Hasnida Binti Harun, and with my final project topic is about the potential of bamboo biochar as a natural adsorbent for methylene blue dye removal. Several industries including paper, textile, plastic, cosmetic, and printing use chemical processes that involve synthetic dyes, which are frequently discarded as untreated waste and end up in water resources. So this disposal of wastewater containing natural dyes into the river flows then poses a serious problem to the water life, food nets, and cause damage to aesthetic properties environment. Therefore, biochar, being environmentally friendly and extremely versatile, has been seen as a novel material for treating wastewater treatment. So, heterocycloaromatic hydrocarbons are one of the industry byproducts that known as a threat to the environment. Due to its toxic and mutagenic properties, the presence of this hazardous compound in seawater, river sediments, and groundwater negatively impact to human health. Dyes are released into the environment during dyeing process, making the effluent highly colored and aesthetically unpleasant. As a result, aquatic life dies, solid deteriorate, and drinking water become contaminated. So here, the objective is to develop biochar as an adsorbent from bamboo waste and also to investigate the effectiveness of the biochar in the removal of methylene blue from an aqueous solution. So the significance is bamboo represents economic and environmentally friendly alternative to conventional adsorbent commercially in activated carbon. So this study used bamboo waste as an adsorbent and methylene dye blue as an adsorbent. Thus, heavy metal or dyes in the environment has been one of the major issues owing to economic and environmental factors. Therefore, adsorption is one of the methods commonly used to remove dye from aqueous solution with relatively low metal ion concentration. In literature review, bamboo is a genus of plants that belong to a family of gigantic woody grasses. According to Hamid in 2017, currently there are 70 different bamboo species have been identified in Malaysia. Bamboo has same chemical component with wood varies in hemicellulase, cellulase, and lignin, which making up more than 90% of total mass. Bamboo is also widely used for multiple purposes. Traditionally, bamboo may be used for almost everything from scaffolding to boots, furniture, food, and thousand other things due to its quality and versatility. Other than that, more recent science has taken a new look at bamboo using in research to improve wastewater treatment. In addition, during its growth, bamboo has the ability to absorb large amounts of nitrogen from soil and carbon dioxide from the air, which will surely aid in the reduction of water and air pollution. Thus, with the advancement of science and technology, the chemical modification of bamboo called pyrolysis of bamboo enhance the properties of bamboo by extending the bamboo fiber application according to Suhaili in 2013. Adsorption is a surface phenomenon with common mechanism for organic and inorganic pollutant removal according to Rashid in 2013. Adsorbent is the exposed solid surface where the other molecules are accumulated during the adsorption process, and the substance that becomes concentrated in this surface is referred to as an adsorbate. The type of adsorbent. The first is natural adsorbent. The material used as low-cost adsorbent as natural coal, clay, peat, and zeolite. The second is industrial and agricultural waste or byproduct. This can consider a very good adsorbent and have the ability to remove dye from industrial effluent due to their psychochemical features. Adsorption parameter. Capacity of biochars depends on various factors such as surface area, pore size distribution, surface functional groups, molecular size of the adsorbate, solution pH, and the presence of the other ions in solution. The characterization of adsorbent can be determined by the analytical procedure such as scanning electron microscopy, Fourier transform infrared spectroscopy, and X-ray diffraction. According to Singh in 2013, dye is colored, ionizing, and aromatic organic compound which shows a affinity toward the substrates to which it is being applied. It is generally applied in a solution that is aqueous. So the sources of dye is from the textile industry, is a major large volume of water and chemicals for processing the wet units. It produced the total volume of industrial wastewater about 22%, which has contained organic and inorganic compound in high concentration, based on Siti Zuraida in 2015. According to Katasaran, Kasendo and Lau in 2018, the balance of dye mixture at the finishing process is about 85% of dye wastewater has been discharged. Classification of dyes divided into two. The first is natural dye, that can be derived from without any chemical treatment, are used to color a variety of items, including leathers, textile, papers, and foods. The second is synthetic dyes. Synthetic dyes can be derived from organic and inorganic compounds because they have a high visibility even at very low concentration in water. So here, dyes can be impact to aquatic life and environment, especially human, such as allergic skin, reaction allergic dermatitis, skin irritation, cancer, and mutation. In this chapter, describe the experiment procedure of bamboo biochar as a natural adsorbent to remove blue methylene in an aqueous solution. This section provides a list of material and procedure for a batch of adsorption experiment in treating dimethylene blue effluent. So this shows the methodology flowchart that flows the of study that will be conducted. So the first of all, the collection of bamboo, which is we make a pre-treatment to the collection to remove any physical impurities on the surface of the bamboo and further cleaning using distilled water before dry under the sun. And after that, we make a preparation of methylene blue, which is a stock of solution 1000 mg per liter of MB dye solution is prepared. And after that, we make a batch adsorption test. And after that, to know the potential of the bamboo biochar as an adsorbent, determined from the moisture content, volatile content, ash content, carbon yield, XRD, SEM, then FTIR, and to investigate the effectiveness of the bamboo biochar to remove the MB dye solution from the optimization of parameter, which is contact time, adsorbent dosage, and initial concentration. And after that, we make a treated dye and to achieve the standard, which is standard A or standard B, according to the industrial effluent for mixed effluent. And after that, we make analysis and discussion and make a conclusion that we get from this experiment. In methodology of bed adsorption test, the applicability of bamboo biochar as an adsorbent in methylene blue dye is studied. The effect of contact time, adsorbent dosage, and initial concentration parameter are investigated. To determine the initial concentration of a dye, MB, a 1000 mg of dye and then dilute into mass concentration 50, 150, and 300 mg per liter MB standard solution. To determine the effect of adsorbent dosage on the adsorption, 0.5, 1.5, and 3 grams of bamboo biochar and 100 ml of MB solution with a mass concentration of 300 mgl are added into a conical flask. Then mix and adsorb them at ambient temperature for 60, 120, and 240 minutes. And the adsorbance is measured after filtration. The adsorption capacity and the removal rate is calculated, and the effect of the initial mass concentration on the adsorption effect is calculated. All the experiments conducted in triplicates and the average value are presented. In this chapter, based on biochar adsorption process that apply on bamboo biochar, few yields hope to be achieved, which are to develop biochar as an adsorbent from bamboo waste. Unlike common biochar made from agricultural waste, bamboo biochar has relatively large pores suitable for the adsorption of large molecules. This is due to surface area. Bamboo biochar makes it an effective adsorbent. Millions pores can trap and store vast amounts of pollutants and other harmful substances. Biochar absorbs dyes by trapping them while air and water flows through the pores, purifying the surrounding air or water. This indicates that the bamboo has higher adsorption capacity. The bamboo biochar is effective in removing the diblumethyline in aqueous solution. The three variables, which are contact time, adsorbent dosage, and initial dye MB concentration, is the parameter that is used to obtain the optimization of dye removal in operating conditions for the clean aqueous solution. This result can be proved that the adsorption process by using natural adsorbent which is bamboo is an effective adsorbent starting as material to modify raw bamboo to biochar. Therefore, biochar bamboo can be as an alternative for dye removal and become demands in the future since it is one of the natural, waste-friendly, cheap and available resources in Malaysia. So that's all for us. Thank you.